Welcome back to Scoreline. My name is Harish. Today, let's look at 5 geometry questions that go through a wide range of the geometry topics on the SAT. Alright, so basically, let's get started with this question. A rectangular metal sheet has an area of 240 square inches. A larger version of the sheet is manufactured in which the length and width of the original sheet are increased by 60%. What's the area of the larger sheet in square inches? So usually we can use the scale factor to get this. So what is a scale factor? Well, in this scenario, one of the sides, oh yeah, let me just draw this for you guys. So let's consider a scenario where this is a rectangle and this is another rectangle. This is S, okay? This is 1.6 S, right? Because it's 60% greater than. So you can just say this is 1S if you'd like, but there's no point in doing that, right? So 1.6S and S. So what's the scale factor here? For the side length, 1.6. So for area, we need k squared. So what's k squared? 1.6 to the power of 2, 2.56. So if we multiply 2.56 by 240, we get 614.4. And we can do that problem relatively quickly. Awesome. There's also another way you can do it. And honestly, I want to show that. You guys can do it whichever way you like. If you don't necessarily want to do the scale factor, there's another form of scale factor that you can use. And this is not in my previous video. So if you want to listen, you can. So consider the length and width of the first circle. Let's say xy, right? And the second one is going to be 1.6x times 1.6y. If that makes sense, then yeah. So then this actually just results to 1.6 squared, which is 2.56 xy. So that means that the area of this is 2.56 times the initial area. Let me put x1, y1, xf, x2, y2. So the area of the bigger one is just going to be 2.56 times more. So that's why we get 614.4. This is technically scale factor. It's just a different way of visualizing it. Let's go to the next one. Assume the triangle drawn is acute because it looks just like it. Oh, do not assume the angle is acute just because it looks like it. What's the measure of TUR? So TUR, that's this angle right here. So let's just deduce it one by one. So first, let's try to find this angle, because what we're looking for, there's technically, 3 triangles in this giant shape. There's one triangle, QXS, there's RWS, and there's RUT, okay? So let's first find the two known values. Let's first find the angle S, because that's the easiest one to find, right? So 88 plus 36 and 180 minus that gives us the angle value of S, which is 56. Okay, now that we have that, 56 equals S. I'm just going to write that. Then for this angle W, we can just do 180 minus 98 equals 82. So equals W. Ugh, I can't do that. Okay, I'm just going to do 82 equals W. So then, oh, Desmos doesn't like you if you set it equivalent to something like in the end. So just do it in the beginning. All right, so then 180 minus S plus W is 42, which is angle R. All right, so R equals 42. Then we just have one more piece of the pie. 180 minus 155 gives us the angle T. So now that we have R and T, we can find U. Whoa, what did I do? What did I do? What did I do? What did I just do? Okay. Sorry. So 180 minus S minus W gives us the angle R. Sorry, I messed up a little bit there because I pressed backspace on Desmos way too many times. But then what we're going to do is 155 minus, 180 minus 155. And that's equivalent to T. Okay? So 180 minus T plus 42. 42 is just R, right? So then the angle U, or TUR, is 113. Next question. Oh, this is an interesting one. Okay. Circle has a center N, arc length is 6 pi, and Y is equal to 80. So, how do I want to go about this? Okay. So we know that the arc length is 6 pi. 6 pi over... Okay, the arc length over the area, the degrees, is equivalent to 2 pi r, the circumference, 2 pi r, over 360, right? So now that we know that the radius is 13.5, what we can do is set up a proportion with the rest. So if we subtract 80 from 360 to get the value of this angle right here, that like this N angle, what we can do is get the angle value for that. So 360 minus 80 is 280, right? So 280 over, let's say, or let's just keep the same like relationship as the first one. So S, which is this arc length, JKL, right, over 280 is proportional to 2 pi r, but now we know r, 13.5 over 360. So then we get the value of S. And you're saying like, bro, none of the answers match it. That's because the answers are in terms of pi. So in order to get the answer in terms of pi, all we need to do is type in all these answers. 14 pi. No, that's not it. 18 pi. No, that's not it. And 21. Bro, oh my god, I keep doing this. Sorry, guys. And 21 pi, which is the correct one because it matches it, right? So then the answer is C. Next one. Bruh. Okay, this question is really easy. You just need to understand the equation of a circle, which I did post a video earlier on that, so you can go ahead and check that out. But basically, you can get this answer almost instantly. I think, right? Yeah. So it's asking us what's the value of 3D, and the value of D is just this, and circle Q has the same radius. So honestly, bro, I don't even need to read anything else if I just want to get this question right. But let me just read it just in case. And it's translated 55 units to the left. So D, if you guys didn't know, in this scenario will be r squared, the radius squared. But technically, we don't have to even solve for the radius of this one. Because if the same radius is there, then the same r squared value will be there, right? So what's the value of 3D? Well, it's 13 times 3, which is 39. And that's the correct answer. Oh, okay. Wait, let me just pull up the reference sheet real quick. So as seen in the reference sheet, we have some special right triangle rules here. So for this one, it does say that it's isosceles. Isosceles means two angles are the same, and it's a right triangle, meaning it's a 45-45-90 triangle. So based on this relationship, it's really simple now, just because of the reason that we know that S plus S plus S squared is equal to the perimeter. So what we can do is say 52 plus 52 square root of 2 is approximately equal to 2s, because from the reference sheet, because like I just said that expression, plus s square root of 2. You might be saying, well, since this is 52, then s is 52, right? Well, if s is 52, it wouldn't really work out. So I think it's best, because the hypotenuse value of s root 2 is actually not this expression right here. It's actually this, which you might find weird, but sometimes something multiplied by a square root gives a whole number, whereas the adding the two legs does not give a whole number. So we're going to see that here. So let me just make that correct. Okay, 52 plus 52 root 2 is equal to 2s plus s root 2. So s is equal to 36. What we want is the hypotenuse, which we know is s square root of 2, which is 52. So you might be understanding, like you might be asking, bro, what? I thought you just said the hypotenuse is always s root 2. That is, the hypotenuse is s root 2, but in this case, the hypotenuse just so happened to be a whole number. So if you might ask me for a method to get this type of question right every single time, what I tell you is, honestly, set up an algebraic equation just like I just did, and make Desmos do it for you, like I just did. So yeah, these 5 questions are sometimes can be interpreted as hard, but they're actually pretty easy. Thank you for choosing Scoreline. All these questions can be found on Oneprep, which is an aggregate of the SAT question bank. Thank you so much. Harish, out.